Thank you. All right, hello everyone. My name is Robin, and in the past 7 years, I have passionately loved three things. First of all, the most beautiful woman in the world, who I've known for 18 years, dated for 16, and we've now been married for 2 months. Secondly, our amazing son, who was born last November, and who already has more hair on his head than his dad. Finally, thirdly, my mistress. The only one I ever cheated on my wife with. Oh, it's okay. She knows about us. I wouldn't say she approves. I don't think she really understands. But as she said to me last week, Robin, it could have been worse. You could have become a React developer instead. So, now, as you can imagine, this kind of extramarital affair can have a big impact on any relation. And for us, my first talk on H3 was actually in 2018 in London, and my wife went along because she loves the UK. And we also took a trip to the Harry Potter studio tour because we actually met on a Harry Potter forum 18 years ago. And this is where I decided to propose. I actually went down on one knee in front of the Hogwarts Express. And despite all that, she still said yes. And so we started planning for a nice spring wedding on the 9th of May, 2020. When that obviously couldn't happen, we decided to postpone long enough so that the pandemic would definitely be over. So we had a date in March 2021. And so long story short, we finally got married 2 months ago, and I can say this was indeed one of the best days of my life. Thank you. Now, why am I telling you all of this? Well, it's because HP3 has had a relatively similar trajectory. It started in 2012 at Google as part of the Quick project. It was then transferred to the Internet Engineering Task Force in 2017. That's the organization that actually standardizes these protocols. It was renamed to H3 in 2018. And ever since then, whenever people have asked me, when will it be done? I've always said, well, not yet, but definitely next year. Definitely. And so very predictably, it was standardized literally 2 weeks ago. Right? Now, luckily, this doesn't mean that we have to wait until now to actually start using it. In fact, most of the major browsers have had H3 enabled by default for quite some time now. And Safari is now finally catching up in iOS 16. That means that, for example, according to Cloudflare, they say that already 26% of all their traffic is running on H3. And there are some other sources up there as well, and they claim let's say, between 20 and 32% is all H3 today. This is why today I thought it would be interesting for me to explain how you might start using this in your own projects as well. So the original title for my talk was going to be Hands-on with my mistress. For some reason, the Smashing team didn't really like that. But that's basically what it's going to be. So I'm going to explain what it is, how you can set it up, how you can test it, and what you can expect. Now, what is H3? If you're using a protocol, you're not just using one, you're actually using kind of like a wedding cake. You're kind of using like a layered stack of them. And what you probably know as HTTP is really only the top layer of this stack. These are the things like the headers, the status codes, how you use it in JavaScript. This is something that actually doesn't really change all that much between versions. What does change is how this stuff gets transported on the network. And that has changed a tremendous amount for H3. So much that I could not possibly discuss all of it today. Luckily, there's someone who has written a few blog posts on this on the Smashing website, so please check those out. For today, you really only need to know 2 things. The first one is that these bottom 2 things, they are really quite different. One of the main ways this matters is that the UDP stuff is actually often blocked on many networks. This is because historically it's been used a lot by attackers to do things like denial of service attacks. And so a lot of network administrators will block UDP except for a few use cases like DNS. This is a bit unfair to H3 because Quick actually has a lot of mitigations in place for these attacks, and it's quite safe to use. Still, most network administrators want to wait until their firewalls have support for the protocol, and this is expected to still take quite some time. And so a lot of networks will remain blocking H3 for the near future. That's one. Two is, of course, why do we want to use H3? And that is mainly because of performance. It has a lot of new features like head-of-line blocking removal and connection migration and better packet loss detection and all those things. Very interesting technically. You can even do a PhD on it, I've heard. But, according to me, primarily micro optimizations that will mainly matter for a small section of users in specific situations. The one performance feature that will impact a lot of users is the faster connection setup. So let's explore that a bit more and start with HTTP2. A lot of these protocols, they actually have to do something up front, which is called a handshake, a kind of initialization of state. We start on the bottom with TCP, then comes TLS to set up the encryption, and then we get the HTTP request, and then we get the response, which is usually the first 14 to 50 kilobytes of your HTML document that you get in. Now this takes a bit of time on the network. This is called a round trip time, and depending on how far the client and the server are from each other, this can actually start to take quite a long time, up to 200 milliseconds and even more. And if you have to do that 3 times, that means your browser is basically twiddling its thumbs for over half a second until it gets useful data that it can do something with. This is why H3 is so important. Because as you see here, luckily, UDP does not require a handshake. Excellent. And QUIC actually integrates with TLS in such a way that we can do both of their handshakes in the same round trip, saving a full one on H2. And it gets better, because H3 actually has another mode that it can work in, which is called zero RTT, which allows you to do all of these things in the very first round trip. This doesn't always work. It is a bit fiddly. It, for example, needs a kind of an encrypted cookie that is negotiated in a previous connection and so on. But I think Google sees between 60 and 80% of the times that this will work, depending on if you're on mobile or desktop. So quite nice. There is a bit more nuance to this, though. In all fairness, H2 can also use a kind of a zero RTT mode. It's not as good as H3, but it still is only 2 round trips then. And on the other end, QUIC actually also has quite a few failure modes that I've listed here that can cause it to take an extra round trip during the handshake, or that can cause zero RTT to fail and needing an additional round trip to get the first HTTP data as well. This is especially the case if you have a badly configured setup. If everything is working as intended though, we expect H3 to be 1 or 2 round trips faster than HTTP2, which can be pretty major. That alone should be enough to convince you to try it out. And how you do that, I would like to compare that to planning your wedding party. Because for both H3 deployment and a wedding party, there are 2 ways you can do this, the easy way and the hard way. For our wedding, we took the easy way. We found this amazing venue. It's like an old medieval granary with these big chandeliers, basically the closest thing I've ever seen to the Hogwarts Great Hall. And they basically provided everything. They had a caterer, they had a DJ, they had the decorations, all of those things we could use from them. Sure, we paid a little bit more for the service, but that was definitely worth it if the alternative is doing all of that stuff yourself and then also having to clean up the mess the day after, right? And this is going to be the same for H3, at least on the back end. I've got good news first for the front end people among you, because you really won't have to change anything. This is very different from 7 years ago, if you remember, when we switched from H1 to H2. If you had an optimized setup then, you had a lot of work switching over to H2, a lot of headaches. This is not true this time around. If you have a page that works very well on H2, it will still work very well on H3 as well. You can sometimes even get away with a little bit more relaxed requirements. For example, I think for H3 we can start using a few more connections again, especially if you're using zero RTT. One thing you should not use even now though is server push. I'm sorry. It is still in the standard, but that is mainly because they wanted to keep feature parity with H2, not because it's suddenly a good idea. Instead, you should probably be looking at the new 103 early hints proposal that should be coming up that does something similar. Other than that, just keep doing what you're doing, and that'll work just fine. So the front-end people can go to sleep now. That's fine. And the back-end people, well, actually, you can also go to sleep, because the easy way of setting up H3 is very simple. It's just use a CDN. Right? All of the CDNs, most of the CDNs were very actively involved with H3 from the beginning, meaning they already have a very mature offering right now. Even the ones that don't, like Amazon and Azure, are actively working on it and expect this within a few months. What's more, enabling H3 on a CDN is literally as simple as flipping a switch. That's it. Let's look at what that actually means, though, because that might not be obvious. As you may know, what a CDN really does, it interjects what are called edge servers between your client and your origin server to improve performance. When we enable H3 on the edge, we of course will only get H3 between the client and the edge. Between the edge and the origin, that is going to remain H1 or H2. This is actually good because that means you don't have to change anything about your origin setup. That can just remain the way it is. You can still get all the benefits from H3 this way. There's a little bit of a caveat though, because some of you might be running a more or less hybrid model, where the client does connect to your origin directly for some things. This is not optimal, but the good news is this does work. In fact, a lot of you, if you're using something like Google Fonts, are already doing this, because Google Fonts are hosted on Google CDN, which of course supports H3 as well. Now, to get an idea of how easy this is to enable, I asked Tim Verreke from Akamai to send over some graphs from his scalemates.com landing page. You can see here, the moment he flipped that switch, immediately he saw up to 13% of all his visitors using HTTP3. This means it's very easy to simply flip the switch, gather some data, see how it does, and then turn it off again until you are sure everything is stable and you can leave it on by default. Now, one thing you might be wondering is that number. That seems a bit low. Earlier I said 20 to 32%. No, 32%, yeah. So 13 seems a bit low. And it gets weirder because this is for the landing page, the index. If you look at the data for all the other pages, suddenly the H3 share shoots up to about 50%, higher than H2. So what on earth is going on here? And this is something new for H3, which for this talk I've liked to call the RSVP problem. You probably know if you send someone an invite, you want them to let, for example for a wedding, you want your guests to let you know if they're coming or not up front, so that you can, for example, order the correct amount of food. This is often called, I think at least in the US, the RSVP, which comes from the French, répondez s'il vous plaît, which roughly translates to, please reply, or else. The last part is silent because it's French, right? But basically, you want your guests to know what they're going to do ahead of time. And this is exactly what we have for H3 as well. Your browser is not going to want to use H3 to your server because a lot of servers won't support it yet. And even if they do, the client's network might be actively blocking UDP, as we discussed before. So what the browser wants to do is only try H3 if it's 100% sure the server supports it. How on earth will it figure out that? Well, by using an RSVP mechanism. It's not literally called RSVP, of course. It's called another letter soup. It's called Alt-SVC, which stands for Alternative Services. The way that works is that the browser, if it hasn't seen your server before, it will first connect to it using only H1 or H2. What it then expects your H2 server to send back is an HTTP response header called Alt-SVC, which indicates that, hey, the server also does HTTP3 on a given UDP port number, which for almost all of you will always just be 443. The browser is then going to store this information in what is called the Alternative Services cache. For how long? That is controlled by the additional parameter there, the MA, max age. In this case, it will store this for a full day. This is again a way to control how aggressive your H3 deployment is going to be. After that, if the browser needs to make a new connection to your server, and H3 is in the alternative services cache, it will actually open 2 parallel connections. One over H3 and another one over H2 or H1. This is primarily, and we'll then use the one that connects fastest to load the page. This is primarily done so that even if the client's network blocks H3, you still get an immediate fallback to HTTP2 without the user knowing anything about what's going on. There we go. So with that flow, it actually makes quite a bit of sense what we were seeing here, right? On the landing page, these are probably newer users or users who return after a day of absence, and so they will start off using HTTP2. All the other pages will have the alt services cache primed, and they will start using more and more H3. The good thing is, all of this automatically comes set up if you're using the easy way with the CDNs. Now it's time for the hard way, and that is if you want to do this on your own origin setup. It is definitely possible, but it's difficult because the typical servers that you probably use, things like Nginx or Apache or Node.js, they were not part of HTTP3 from the beginning, and they are still playing catch-up. Some of them will take months or even years to come out with a stable offering that you can actually use in production. There are other servers available right now that can offer you this right now, but these might be a bit more difficult to integrate in your existing setups, depending on what you're doing. For maximum power, you should probably be using the open source implementations from the bigger companies. Those have all the features, all the goodies, but they are also super complex to configure correctly. You really need a good technical team that understands these protocols in depth to get proper performance out of that. Because these companies, they share their open source code, but not their production level configuration, obviously. Even if you get that set up, there are still a lot of other problems you have to deal with, things like firewall configuration, load balancing changes, and so on. And this is where I have a little bit of fake news in this presentation, I'm sorry. The blurb said that I was going to talk about Elvis-officiated weddings in Las Vegas, and I promise you I tried. I tried to fit it in, but it would have taken me so much time, and I really hope none of you ever have to deal with that in practice, so it's not in. But if you want to know about this, ask me afterwards. And of course, you can still look at the Smashing blogs as well, which detail some of these issues through. Let me just say it's indeed quite involved to do this at this point. This should improve in a while, but not the first few months or even years. So, use a CDN. No matter what you use, however, once you have this set up, you're probably going to want to start testing your setup, how well it is performing. To understand that, you first need to know that I, for very complex linguistic reasons, have a fascination with the amazing rhinoceros. And most of my family and friends know this, and they often give me this kind of quirky gift. I even have a rhinoceros tie on me right now. The problem is that one of the guests at our wedding, they apparently kind of misinterpreted this to mean that I like all things horny. Not in the way you're thinking, probably. Actually, this is what they gave us. Like a custom drawing of our little family and this team. I can genuinely say, one of the nicest gifts I have ever gotten in my entire life. I especially like the idea that they felt they had to give the dad a tie, because otherwise it wouldn't be clear that the bald narwhal was me, you know? So amazing gift, but the problem is, neither me nor my wife have any idea who gave it to us. It was in an unmarked wrapping paper. There is a signature on the back that is completely unreadable. We asked the usual suspects, the people we know can draw like this, and none of them said this is from us. So it's kind of starting to get a bit embarrassing because we have to start asking people, did you give this to us? Now where I'm going with this is that once you start testing these things, you will get probably some nice results. But figuring out where they actually come from, what is causing these results, can be quite involved. And luckily for things like HTTP3, it's easier because we have a lot of good tools, right? I'm going to start you off easy because the first thing you probably want to do is check if your deployment is working. For that, I would recommend to use http3check.net or the curl command line tool. Both of them will first load the page on H2, get back alt SVC information, so you also check that, and then it starts to try and initiate an H3 connection and gives you a lot of information back on that. What you can also do is in most of the browser's DevTools, in the network tab, there is actually a hidden column usually that is a protocol that actually shows you what is actually being used. Now that's only the beginning. What you probably really want to do is compare H2 to H3 performance. And some of the tools you might be thinking about using for that are, of course, Google Lighthouse or the built-in browser DevTools. Why wouldn't you? These are amazing tools for web performance testing. You should be using them, but not for this, not for protocol testing. This is because while they include network throttling abilities, they actually do this in a very unrealistic way. They don't actually change anything about the network. They will actually just ingest all the data at full speed and then artificially delay it inside of the browser, adding a little bit extra simulation logic on top to make it more realistic. This is usually good enough. This usually gives you an idea of what your site would be doing on a slower network. But of course, for these low-level network things, this is not going to cut it. For that, we're going to need something more advanced, and that is, of course, the best web performance tool that we have to this day, which is Web Page Test. Web Page Test has an amazing built-in network throttling suite that actually does things correctly. It does change the underlying network configuration parameters, at least as well as we know how to do it today, without actually running on a real network. Simply using Web Page Test, though, maybe still not enough, because what we want to do is, of course, compare H2 to H3. We want a full page load on H2, and then a full one on H3, and that is difficult because of alt SVC. You're always one load behind. And so one thing you might think about using, if you know a bit about Web Page Test, they have this feature called repeat view. And so they will first load the page from a cold start, and that will be our H2 load. And then, without clearing the caches, it will load the page again. This means our alt SVC is now primed, and that should use H3 internally. This, of course, has a lot of problems, because if the caches are primed, H3 is always going to be much faster, because it also has a lot of resources cached. So that's not a very fair comparison. But it gets worse. Apparently, I've been lying to you. Apparently, a lot of the browsers, they don't actually wait for the second page load to start using H3 if it's available. A lot of them will actually initiate H3 connections during the first page load even. If that works, they will actually switch to using this new connection. And so what you would get is kind of a hybrid result of a little bit of H2 and a little bit of H3 mixed in, which is, of course, not very useful. And it gets worse. It turns out that in a lot of my tests, not all, but a lot, it seems like alt SVC wasn't actually working. The repeat view would also start with H2 and only later switch to H3. I still have no idea why. It could be a browser bug, it could be a web page test bug, it could be something else. But the real thing is, it doesn't really matter, because you should not be using the repeat view option for these comparisons. What you should, or what you want to do instead, is to force H3 or H2 to have a fair comparison. Luckily, the Chromium browsers, they have a few command line parameters for that you can also set in Web Page Test. The main one here is called origin to force quick on, which does require you to have a full list of all the individual domains that you want to use H3 on. So that's a bit annoying, but it works. And using these parameters will actually skip the alt SVC flow and use H3 directly from the first connection onward. Conversely, luckily, disabling H3 is much simpler. It's just a single parameter. And so using this, you can actually get a very good comparison between H2 and H3 in Web Page Test today. Sadly, only for Chromium browsers. I am not aware of any way to do this for other browsers, at least not from within Web Page Test. Even then, though, you get a nice comparison, but it can be difficult to figure out if things are going wrong. This is because there is no easy way yet to dig deeper into these things in web page test. You can't look at is zero RTT being used or not, how many round trip times are in the handshakes or not. All of these things are not yet freely available. And looking at this, I also found quite a few bugs still in web page test for this, especially inside of the connection view. For example, here, for H3 connections, it sometimes only shows like part of the handshake connection setup. It sometimes shows nothing for the connection setup, very strange. And sometimes it shows just one of the different things. And I found neither rhyme nor reason which is the logic behind that. One of the funniest bugs that I've actually encountered, well, funny if you're a protocol dork, is with the connection coalescing feature. You don't need to know what that is, but basically what web page test is telling us here is that Fastly.com, Google Analytics.com, and Drift.com are all being hosted on the same server, on the same IP, and can be loaded on a single H3 connection. And it does a DNS lookup halfway through. Now, I'm not an expert, but this looks like a bug to me, right? And now I am not trying to cast shade on the web page test team. They are amazing. This is just very complex. It is very to be expected that something this new and complex has some bugs. The good thing is that the information we need to solve these bugs is actually available, even within web page test. We have access to low-level network packet captures. We have browser networking logs. The main thing we need to do is expose this to the higher level interfaces. And I actually hope to find a little bit of time myself in the coming months to hopefully contribute some of this to web page tests, so that hopefully next year we will have a fully fledged HTTP3 debugging tool in this. Now, I've mostly been talking about what they call synthetic testing or lab testing. There's, of course, also real user monitoring, RUM, where you get data from real users. This works, we'll see this soon, but this will still not give us the very low-level information that you might need because you rely on high-level JavaScript APIs for this that do not expose this, right? So let's say you have deployed it, you have real user monitoring set up, excellent. What can you expect to see in the results? First, it's time for another anecdote. It's all about expectations. What we really wanted for our wedding was for our guests to dress to impress. So on our invite, I think the dress code said something like, the gentlemen need to be wearing a suit and a tie, and the ladies should have a long dress, right? And we thought that would be enough, and for most of the people it was, until these two showed up. And if you can't tell from the picture, they basically came in full-on Harry Potter school uniform cosplay, right? Technically adhering to the dress code. Not exactly what we had in mind, though, okay? And the point is, again, if you are testing these things, you will see results that you may or may not expect showing up like that. The other thing I wanted to tell before we dig into the numbers is that protocol performance is very rarely low-hanging fruit. This means that if you are currently sending down 2 megabytes of JavaScript and 25 unoptimized images, just switching to H3 is probably not going to do that much for you. You really need an already relatively optimized page, and even then you will mainly see improvements for your slowest 10 to 1% of users, the so-called P90 to P99 percentiles cohorts. This is illustrated nicely in a very recent blog post on gov.uk, where they found these very slow users, for example. Some of them were trying to load the page from very far away, again having larger network delays and so on. So this is where your main benefits will come from. With that, let's look at some numbers. We have some very early Google Quick results. They used this for their Google search, obviously, already very optimized. What they were measuring is how long it takes for the user to put in the search query, and they see the response come back. And they were able to improve that by up to 16% for the slowest 1% of the users, which is amazing. Then for YouTube, they were able to reduce the amount of times it stalls, so it has to buffer the video, by up to 20% in India, which at least at that time was a very poorly connected region. These amazing results is what eventually prompted the IETF to adopt H3 and make it into a standard. Now these are a bit old data. We luckily have also much newer numbers. Late last year, they were shared by Wix on Twitter. Wix is a kind of a low-code website building platform, and they are using the Fastly CDN for their H3. And they were looking at the time to first byte metric, which should correlate very well with the connection setup improvements. And indeed, they found very impressive things, up to 50% faster time to first byte, translating to over half a second faster in some countries, which is completely bonkers. It is at this point, though, that you should start getting critical and thinking, this seems too good to be true. Is this correct? Because if you've been paying attention, what I've explained earlier is that on H2, we would expect to see 3 round trips. That means that on H3, we would have either 2 round trips, which is 33% faster, or 1 round trip, which is 66% faster, but nowhere in there should we be expecting 50% faster. Where is this 50% coming from? So we discussed this with the people from Wix at the Web Performance Slack group, which is probably all join. And what it turned out to be was how they were defining the time to first byte metric. Time to first byte is not something you just get from the browser. You actually have to calculate it yourself from the timestamps in, for example, the resource timing API. And its default definition says that you also have to include, for example, DNS lookup times in this metric. And now from what we've learned today, we know that H2 is often going to be used for the very first page load, which means it's also very likely to incur a DNS lookup. Conversely, H3 comes directly after that, and it's very likely to have the DNS data cached, so it doesn't have this overhead. And this is where the 50% comes from, 4 round trips versus 2. Now, arguably, this is not very fair to H2. It shouldn't really include the DNS overhead because it's not really part of the protocol. And so what is a much fairer metric to use, a more honest metric to use, is to only look at the actual connection time, which I've here called honest time to first byte. Wix went back, made changes to their setup, and they had an updated graphs for us. And indeed, here we see for most cases, we get about this 30% faster page load times. Right? This means that, clearly, Wix was not using 0 RTT at that time. Otherwise, this would have been 66%. Right? And very recently, I contacted them again in preparation of this talk. I said, do you have any new interesting stuff for me? And they will share some information on, for example, the largest contentful paint web core vital. Now, this is a bit not a fair comparison again, because for H3, this only includes warmed cache page loads, so repeat views, while for H2, it includes both repeat views and cold starts. So it's not a perfectly fair comparison. I would see this more as like a best case, what you might expect. And in that case, we see up to about 20% faster largest contentful paint, which I think is, simply amazing. Very interestingly, Microsoft actually found very similar things when looking at their Outlook web app deployment. They also found problems with the DNS and the time to first byte metric. Even when correcting, though, for the slowest 1 in every 10,000 of their users, P99.99, they actually found H3 to be up to 64% faster. Why? This is where those micro optimizations that I talked about earlier come into play. This is where H3's better packet loss handling actually starts to pay off. So still very powerful, but not for all of your users. Finally, a lot of people in the community, they have been sharing a lot of blog posts comparing this on their setup. I'm not always the biggest fan of these blog posts. A lot of them are not very nuanced. They don't talk about alt SVC. They don't talk about some of these problems that we've seen today. And so it's very unclear if their results and their conclusions are actually true. This is one of the better ones I found. It is far from perfect, but still interesting to look at. This is Love Holidays. They, again, use Fastly as a CDN, and they see somewhat less impressive results. They get up to 18% faster time to first byte, and not that much for largest contentful paint. What I think is happening here is that their setup simply was not yet optimized enough to really benefit from all the things that H3 can offer. That, or they made some mistakes in the metrics that they gathered or the way they did it. Even so, it's important to note this, that your mileage may and will vary depending on your setup and the way that you're using it, right? So it's good to be aware of that. With that, I think it's time to conclude. And it's my personal belief that every party should go out with a bang. And I've always wanted to be a knight, and the closest that I've gotten is to do medieval sword fighting as a sport. And one of the people I do this with, he is also a pyrotechnical artist, aka a fire breather. And so we asked him to do like a cool fire breathing show at the end. And after that, we had like an honor guard of like 50 of our guests holding up swords, including 2 flaming ones, through which we then had to walk to leave the party. Now, as you can see, at that time, my wife did not really think that a good idea. But now, she has to agree with me that this was pretty freaking cool. Okay. So let's summarize. What we've learned today, I think, is not HTTP3 specific. It is something that you can apply to anything you do with web performance. First of all, you should probably have a deeper understanding of a performance feature that you're trying to use. You don't have to go super low level, but you probably have to go deeper than what you're used to, because these things can often be severe foot guns, making things slower, and then you have to bring in people like Harry Roberts to try and fix it for you. Or you might leave some performance lying on the table because you're not aware that that was also possible. Secondly, if you claim to care about performance, you should be using a CDN. It really is that simple, not just for H3, but also for many other things that they offer. Thirdly, we are exceptionally blessed in the web performance community because we have a huge amount of very powerful tools. But not all these tools are useful for all the individual use cases. And you should be aware what they are doing internally. For example, the Lighthouse throttling, if it fits your use case or not. And especially for newer web performance features, it might be that there are still bugs, some inconsistencies in there, so you shouldn't really trust what you see on the screen without double checking. As I often say, trust but verify. Finally, when doing measurements, I find it very useful and maybe even necessary to first hypothesize what the results are going to look like before looking at the actual data. That way, if the hypothesis and the data don't line up, you know there's a problem. Either you don't know enough about the feature to do a good hypothesis, in which case go back to 1, or you might have a problem with your methodology, basically what we saw with the time to first byte today, and you have to switch around with that. You can't just trust your data, in our case the 50%, and just believe that is actually what it is telling you. And finally, 5th point, the most important thing of my talk today. If you forget everything else, remember this. If there is ever a contest to select the cutest baby, I win, you lose, not even close. Thank you.
Okay, you're baffling us with cute. I love this technique. That's fantastic. Thank you so much. It's fascinating to see some of these details, and it's certainly an area that I find interesting, but it's sometimes a bit impenetrable to me. So I like the fact that we can lean on experts to do this and inherit some of these benefits. And on that theme, and also there's a couple of things that you said about understanding the use case and what you're building. And also you talked about how if you're already serving a site that maybe has a ton of JavaScript that comes down the wire, you might get very incremental or less obvious optimizations for this. So I guess the question I'm leading up to is, For people who are using like frameworks and leaning on lots of other tooling, to what extent might we need to worry about how they're optimizing for this? Is it something that we have to just base it on what's the use case, or should we be saying, okay, well that framework author will eventually be doing the right thing for HTTP 3, or is it just a it depends question?
Of course, it depends.
Okay.
I think, for example, some things that some frameworks do, you will download the HTML, but that is empty. Then you need to download the JavaScript file, and then the JavaScript file does the JSON request, and only then does it start rendering,
Yep.
right? So you can optimize your handshake as much as you want. You are actively incurring additional round trips by the way your apps are being built. So if that is your setup, then yeah, sorry, H3 is not going to help you.
Right.
So you would have to switch to something like server-side rendering, you know, all the new hip stuff around that, to properly be able to profit from this kind of thing.
Yeah. Yeah, and you mentioned like, it's not going to be like a silver bullet. And on the other side of one of the questions that was added to the docs is, you know, are there any particular foot guns here? You know, what are there cases that there are particular downsides of an evolution to H3?
I wouldn't say foot guns, but it's very easy to improperly configure this if you do it yourself. That's what I was trying to say. If you use the CDNs, they probably take care of that for you. They sometimes make mistakes. I've seen problems with CDNs as well that I've noticed them. I'm trying to think about actual foot guns just with HTTP 3. One of the problems there is, this is a bit technical, but you have like a prioritization feature that details how all of this is working. This has been remade for HTTP 3 from the ground up. It should be much better than H2, but it's not all that well supported yet on all the deployments. And so this integrates with things like preload, things like resource hints, priority hints quite a bit. And if you have the downside of having a server that doesn't do that very well yet, then you might get less than expected performance, even when using H3 correctly.
Yeah. Okay. And perhaps a slightly related question as well is, you know, as we've evolved from, you know, using HTTP to then to H2 and now seeing H3, for those of us who aren't leaning on a framework, or maybe we are, but we're also very careful about the craft of how we structure the delivery of our content, you know, how we structure the HTML and how we bring our other resources in. Do the habits that we've learned need to change, or is there a detriment to us not doing? So, for instance, it used to be the advice to concatenate all of your JavaScript into one thing and load it asynchronously at the end, right? But then as H2 came along, it's like, well, actually, you're better by getting some parallelization from having many resources. Do we need to, as front-end engineers, do we need to change our approach again to get to not hurt ourselves as this evolution happens?
No, it's like what I said in the talk as well. If you're doing this right for H2 at this point, you shouldn't be doing anything different from H3. But a lot of people are not doing it right for H2 yet, right? Just because you don't have to have one big JavaScript file anymore does not mean you can suddenly load 200 smaller JavaScript files or 200 images, right? That is still going to have a particular slowdown. I think I had one of my slides to think like 20 to 40 individual smaller files that should be fine for these kinds of these kind of protocols. There are other things that you might be doing, like for example inlining critical CSS, or trying to get your initial HTML to be as small as possible to fit in like this 14 kilobyte mythical limit, that kind of stuff. That will all still work. That will all still remain best practices on H3 as well.
Got you. Yeah, nice. There's another question that came in referring to something you mentioned about testing and seeing how the impacts came out. You mentioned you can turn it on and turn it off again to see if it was stable or not. And what would you see as unstable if you're using a CDN such as Akamai? Can you give examples of what kind of instabilities you'd see when you mention that?
Not really, but again, there are reasons why. How should I say? There are a few ways in which Quick, even if it works correctly, like on Akamai, it can actually have an additional round trip that you need. One of the reasons for that could be a very large TLS certificate. And that is something you can control sometimes yourself. So if you have badly configured this, even though Akamai is doing everything right, you might still see slower performance on H3, and that's the moment where you want to flip off the switch and try to figure out where that kind of thing is coming from.
Okay, nice. Okay, we've maybe got time for just a couple more quick questions. And one of them, this is a little bit of a tangent, but I've heard some enthusiasm about it. Server push, is that still? Oh, there's the body language. I'm just wondering, is that something we need to be thinking about? Is it going to be available and coming back, or?
Yeah, like I have a strong love-hate relationship with it. I still think it's very cool, very interesting technology, but not for web page loading use case. I would use it on APIs, for example, REST APIs, to make sure that your sub requests are coming in more quickly, that kind of stuff, but not to start pushing CSS or JS or that kind of stuff. We weren't able to make that work, and we have now something new that will work much better for that. And so in the browser, I think push is dead, which is sad because that is actually what started my career in all of this. I started looking into push, but I think it's for the best.
Fair enough. Yeah, I've seen. I think most people I've talked to do kind of make that comment about a love-hate relationship with it, and exciting but complex, and not a straight road. And I guess then, so maybe the last question, just thinking about how this is all evolving and what the future might hold. Are there particular things that you think are maybe coming our way and exciting that we're not ready for yet, but other particular gains and advantages that we might see coming down the line in the future?
Absolutely. This is, I think, one of the main reasons to switch to H3. Even if it doesn't help you much today, the whole idea behind these new protocols is they will be able to evolve very quickly. The idea is they will keep adding features to these in a very fast pace in the coming years. Some things that are coming up, for example, is what is called multipath, where you can use both your Wi-Fi and your 4G, 5G connection at the same time to get additional bandwidth benefits. That's coming up. We have something new called Web Transport. That is kind of like WebSockets on steroids over H3.
Wow.
It will allow all kinds of nice things for gaming and all kinds of stuff.
Yeah.
So yes, this is only the beginning. This is only going to get so much better over time.
Yeah.
So the faster you switch, I think, the better it's going to end up being.
Awesome. I guess my last comment as we wrap, and thanks for such a great talk, is if you are the owner of that one server that has our screen on it, and also the Fastly.com, GoogleAnalytics.com, don't turn that off. If it's under your desk, please don't turn that thing off. Is the last thing I'd say. So thank you so much for an amazing talk, really insightful stuff. Everyone, a big round of applause, I think, for Robin Marks.
Thank you.
Thank you, Robin. Thanks.